Hi friends, in this video I will teach you how to verify the Kirchhoff's voltage law using proteus simulation software. So for that we have to draw the simple DC circuit. For that I take a 3 resistors, 2 voltage source. For taking 2 voltage source I take one battery here. I need one more battery. Why? Because in this circuit I decided to use a 2 voltage source, so that I take a 2 battery, all the components connected in series only. Why? Because I want to make one simple loop circuit. So one battery I place here. I take a 3 resistor, one resistor I connected here, another 2 resistor, one resistor I placed here, another one resistor I placed here. The R3 I make it in vertical direction. I need one ground also. So now I connect all the components in series connection. Before that, this is a simple series circuit. I want to measure the current. So in the series current is common, so one DC ammeter is enough to measure the circuit current. So I select one DC ammeter, then I connect all the components in series manner. So in series manner I connect all the components. So through this circuit I am going to verify the Kirchhoff's voltage law. So just you have to remember what is Kirchhoff's voltage law. The sum of potential rise. In a closed circuit, the sum of potential rise equal to sum of potential drop. In this circuit, battery 1, battery 2 is a potential rise. The sum of potential rise, battery 1 plus battery 2, the equal to the sum of potential drop. The drop across R1 plus, drop across R2 plus, drop across R3 equal to battery 1 plus battery 2. This is a Kirchhoff's voltage law. So in order to verify this, I need the voltmeter. One voltmeter I connect across the battery 1, another one voltmeter connected across the battery 2, another one voltmeter connected across R1, another one voltmeter connected across R2, another one voltmeter connected across R3. So I have to connect the voltmeter in parallel connection. So I connect the first voltmeter. What happened? So this voltmeter plus connected to the battery plus. Similarly, this voltmeter, the voltmeter size is that graphical size is little big. That is the complicated to connect. So voltmeter plus connected to R1 plus, voltmeter minus connected to R1 minus. Here I make it this voltmeter plus I am connected with the minus terminal, so that this voltmeter will reach the minus voltage. This voltmeter will reach the minus voltage. Why? Because voltmeter plus is connected with the minus of the battery 2. That is the reason why it reaches the minus. So always voltmeter should connect parallelly, so that I connect across the component. Each voltmeter connected across the each component. So all the connection is over. Now I have to make the desired values. I set 5 volt in the battery 1, 10 volt in battery 2, 10 volt in battery 2. So R1 I make it 2 ohm, R2 I make it 4 ohm, R3 I make it 8 ohm. There is no any reason. You can fix any values. As per my wish, I make like this. So now all the connections over, all the values are according to our wish we fixed. Say battery 1, battery 2 is the potential rise. So this voltmeter plus this voltmeter reading equal to R1, R2, R3 voltage. Sum of R1, R2, R3 voltage. Okay. Now we have to check. Just run the circuit. Just pass the simulation. See now the battery 1 reads 5 volt, battery 2 reads minus 10 volts. The reason is the voltmeter plus is connected with the minus of battery 2. That's why it reads minus 10 volt. Actually if the battery 1 plus is connected to minus of battery 2, we have to V1 minus V2. That means 5 volt minus 10 volt. Minus of minus 10 volt. That means minus into minus becomes plus. So it becomes the 15 volt. I repeat again, 5 minus 10 volt. So minus into minus plus. So the total voltage will be 15 volt. Now this R1 voltage, R2 voltage, R3 voltage, if we add all these three, it should be 15 voltage. For that I take one calculator. So now I am going to add the voltage across R1, voltage across R2, voltage across R3. The voltage across R1 is 2.14, 2.14 plus voltage across R2 is 4.29, 4.29. The voltage across R3 8.57, 8.57. The total should be 15. So exactly it comes the 15 voltage. Now the Kirchhoff's voltage law is verified. Say suppose if I am changing this battery connection, what will happen? I am rotating this to 180 degree. What happened? Previously the battery 2 minus is connected with the plus of the battery 1. Now I decided better I have to remove all this connection. I take one more cell here. So now the plus is connected with here, the minus is connected with here. Now the voltmeter plus connected here. Okay. Now I make it, this is 10 volt. Previously I set 10 volt, same voltage I will set now also. So in this case the potential rise, we have to subtract all this. This battery voltage should be subtracted with this. Why? Because the battery 1 plus, battery 2 plus are connected together. In this case, this voltage should be subtracted with this. 10 minus 5 means 5 volt. We have to run. What will happen? So just pause. See now the potential rise 10 minus 5. 5 minus 10 volt equal to minus 5 volt. That's why R1 reads minus voltage, R2 reads minus voltage, R3 reads minus voltage. 5 minus 10 volt becomes minus 5 volt is the potential rise. Now we have to check the potential drop. I select one calculator. Say R1 reads minus voltage, R2 reads minus voltage, R3 reads minus voltage. If you add all these 3 voltage, it becomes a minus 5 volt. Let me check. R1 is 0.71 minus 0.71. I take only plus value. We know that the answer will be minus. R2 is 1.43, 1.43.